Okay, this is the Unit 3 test review. Make sure that you're checking your work against my work and also come up with any questions that you have for me. This will prepare you well for your test on Unit 3. Number 1, it says determine which is the better buy. Prove your answer through your work. So you need to show your work for all these. There's a couple ways you can do this. One of the ways is just to use your proportions to solve. But I'm actually going to do it just a little bit easier here. If it's 40 ounces, if it's a 40-ounce bag for $6.80, that means I'm just going to divide. So I can take $6.80 and I'm going to divide it by 40. And when I do that, I get 0.17. So it's 0.17 dollars or cents, so to speak, right? 17 cents per ounce for this one. If I do the 24-ounce bag for $3.60, same thing. I'm going to take $3.60, divide it by 24, and when I do this, I get 0.15 per ounce. So again, they're asking for what is my better buy here. The better buy obviously is 15 cents an ounce. So this one here is the better buy. On the next one we have, on the B one here, we have a 6-pack of pens for $4.74. So we have $4.74. Again, divided by 6. That's going to give me 0.79. So that's per pen. And if I do this one here, I have $12.72, divided by 15, which gives me 0.848. Remember, though, I cannot have 3 digits after a decimal when I'm talking about money. So this 8 is going to tell me to do what to the 4 here? I'm going to raise it up 1. It's going to be 85 cents. So again, better buy then. It's going to be better to buy the 6-pack if I want those pens. Okay, second question here. Put the following in ascending order. You got to remember what this word means. We have ascending and we have descending. And to be honest, I always have to think descending first in my head. So descending I know means go down. So ascending means I'm going up. So in other words, I'm going from least to greatest is what I'm looking at there. Remember, I keep telling you, please, 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 if you do it this way, you're less likely to get it wrong. So put your numbers that they're given in a vertical column. So I have 1%, and again, use the original numbers for right now. I have 10. I have 1 times 10 to the negative 3. I have 1 over 9, and I have 100%. Okay, if you put them in a vertical line like this, now I'm going to go ahead and put equal signs next to each one of these. And I'm going to put my amounts. So 1%, remember what I'm doing here. I'm going to change everything to a decimal. So my decimal's at the end. I move it 2 times to the left. That gives me 0.01. And actually, I want to give myself a little more room here. So let me write it over just a little bit. 0.01. You'll see why in a second. 10 is just 10, but I'm going to put it with a decimal form. So I'm going to keep my decimals lined up. This is one of the reasons why I scooted it over. So it's 10.00. 1 times 10 to the negative 3. It's the same as saying 1.0. They kind of wrote it wrong. Remember, it should say 1.0 times 10 to the negative 3. But it's negative 3. The negative sign here tells me I'm going to go then in that direction to the left. So I'm moving my decimal 3 places to the left. 1, 2, 3, and filling in with 0. So 0.001. 0.001, which means I want to go back and put zeros there to hold my place. 1 over 9, when I do the division, it's going to become 0.111, and it's going to keep repeating. So I'm going to put the line over the top because it repeats. 100% is 1. Remember, it's one whole thing. It's 1.0, and again, put my zeros to hold my place. All right, now that I've done this, I'm going to put these in order from least to greatest. So the first thing I'm looking for is my smallest decimal value. I can forget about the whole numbers and just look at the decimals as if they were whole numbers. So I'm not going to look at the 10. I'm not looking or the 1. That's whole numbers. I'll look at the other ones. This first one is 10. That's 10 there. This is 1. This is 11. So my actually, it's 111, excuse me. So my largest number here, or excuse me, my smallest number is this one. This is my smallest one, which makes this my smallest number because I'm going least to greatest. So I'm going to put 1 times 10 to the negative 3. Put a comma for my next one. This one's done. I'm going to cross it off. Okay, my next one, again, just looking at the decimal values. So again, 10 is smaller than 111. So 10 is my next one. That means that 1% is my next one. So 1% is next, and I've done that. Okay, so 111 has to be the next one. So that means that 1 over 9 is next. And I'm going to cross that one off. And now I'm just down to my whole numbers. Well, which one is smaller, 1 or 10? Clearly, 1 is smaller, so this is next. So I have 100%. That's going to be next. And then my last thing is going to be 10. So there we go. I've got them in order from least to greatest. I thought about my word ascending, going least to greatest. And then, again, write your numbers vertically, as I did here. Make them all into decimals. And then you can easily see which ones are in order. Another key thing, make sure you're putting the original amounts for your answers over here. You cannot put, for example, 0.01 at 0. That doesn't work. So make sure you're doing that. Next one here, really it's the same question. We're doing the same thing all over again. So I'm going to write them all out again. I have 8.27 times 10 to the third. I have 7 over 8. I have 0.32. I have 270%. And then I have the square root of 84.64. Okay? So I'm going to put a little equal sign here next to all these. And I'm going to go ahead and start figuring out what they are. Again, times 10 to the third. This time the number's getting larger, so it's going to the right. 1, 2, 3. I got to fill in with a 0. So this is 8270 point. I'm just going to go ahead and put 2 zeros here for right now. 7 over 8 becomes 0.875. So I actually need one more 0 just to hold my place. 0.32 is still 0.32. But I'm going to put a 0 at the end because I have 3 digits after the decimal in the other one. 270% becomes 2.7. Again, you remember you're moving your decimal only 2 places to the left to get that decimal value. But again, I want zeros here, so we're going to use that. And the square root of 84.64 becomes 9.2. And again, I'm going to add some zeros. All right, same thing we did a moment ago. What I'm going to do to, first of all, actually, wait, what am I doing? I got to double check. I'm doing from greatest to least. So this time I want my biggest number. My largest number is what I'm looking for. Okay, so my largest number here is clearly the 8.27 times 10 to the third. So we have 8.27 times 10 to the third, because that is clearly my largest number. This time I'm actually looking at the whole number part first. My next one is 9. 9 is bigger than 2, so this is my next one. So that means the square root of 84.64. Okay, so that one's out. I've done that. Next one, again, the last one with the whole number is 2, so it's going to be 270%. And so that one's out. Now I'm looking at my decimal values. Which one is bigger? If I forget about the decimal, is 875 or 320 bigger? Well, 875 is bigger. That means 7 over 8 goes next. And that's out. And then I have 0.32 as my last number there. So it's really that easy. If you're putting them in order, going vertically like I did, and then changing it to decimals, you really should have no trouble at all doing these kinds of problems. Okay, number 4, we're just writing this in scientific notation. So I think most people are doing pretty well with this. Remember, I just kind of take this number here because that's my number that I'm going to have a decimal. Remember, 1 digit in front, so 3 point, and then the 49 is going to go after. Because my decimal, one digit has to be in front of the decimal 1 through 9, not 0. And we know it's going to be times 10 to the something. So I can put that down. And now let's see how many times we actually moved our decimal. We moved it 1, 2, 3, 4, 5. That means it's times 10 to the 5th. But we have to think, this was a very small number. That makes it a negative 5. Remember, our negative exponents become our very, very small numbers. And so there's number 4. Number 5, this is similar to what we did a moment ago with ordering, comparing. But this time we're just making sure if they're in the right order. The way I did this is I looked at my equals first. when you look at the equals, when I did this, I did find out that 3 over 25, when I did the division, does become 0.12. And we know that this is 0.12. Okay, so those are equal. That part is good. We also know that 0.10 is less than that, so that's good. And we also know that 0.12 is less than 20, so that's good. That makes this true. The next one, I did the same thing, where I'm looking at this one. And this again was, when I did the 1 divided by 50, it became 0.02. This is also 0.02, but this is 0.02 right here. This is not less than this. This would be equal to this. So this one has to be false. Once you find one false statement in this, you're done. You don't have to look for any more. You might check with the other parts, but we found that that one's false. The other thing here with this is the same thing on this one. 0.8 becomes 0.08, excuse me, 8%, sorry. 8% becomes 0.08. Again, 0.08 is not less than 0.08, it's equal. So again, that's false. And then on our last one here, all of this is true because this is 0.375, this is 0.375, this is 0.375. All of those are equal, and that is less than 0.48 when you look at that. And so that is true right there. Number 6, kind of the same thing. On this one, I changed my fractions over to decimals. So, and also on this, I got rid of my whole numbers. I just looked at the fraction, the decimal part. This is negative 0.78. This is negative 0.75. Remember, they're negatives. This is where it gets a little bit tricky. So I actually drew out my number line off here to the side. I'm going to put my 0 here, and I know I have 2 negative numbers. So negative would obviously be to the left of 0. My negative 0.75, or even if I took it out, right, negative 75 would be there. Negative 78 would be a little bit further down, which makes 78, or the negative 78, less than the negative 75. So this one is clearly a less than sign there. Watch those negative numbers. That just makes it a little bit trickier because it's sort of backward of what you might think. Here, change it to decimals, 0.08. This is times 10 to the negative 2, so it's 1, 2, which is again 0.08. So therefore, this is equal. This one here, 7 divided by 9. When you do the division, it becomes 0.777 repeating. This is 0.770. Remember, it's not repeating. So this one is just barely larger than the 0.770. So watch out. Because it repeats, you can't just go on 77 is equal to 77. For example, if you looked at just the first two here, they're not equal. You got it. This repeats, so remember the 7 goes on forever. This one doesn't repeat, so the number I fill in with has to be a 0. So be careful of that. Okay, number 7, we're talking about getting a laptop. When I first did this, I did all the work, and then I realized what the question actually asked me. So let's look at that first before we start going too crazy. A laptop regularly costs $1,469. It's on sale for 15% off, and there's 4.5% sales tax. Now the question is here, how much tax will you pay? Okay, that's all they want to know. Okay, it's how much tax will you pay on the laptop on sale. So you have a little bit of work to do. First of all, we need to find out how much is it going to cost on sale. All right, so that means I have the $1,469. That's my original price. I'm going to times it by the tax rate. This is, or excuse me, the discount. So this is my discount right here. So that's 0.15. When I do the math, it becomes $220.35. Remember your dollar sign, and also remember to label. This is my discount. Okay, so this is the discounted price. So that means I'm going to take the $1,469 and subtract the discount, $220.35. When I do that math, I get $1,248.65. This again is my sale price. Remember to label. So in other words, when I go up to the cash register, this is what I'm going to pay for it. Now again, they're asking how much tax am I going to pay on the laptop on sale. Okay, well there's my sale price. So now I need to tack on the tax. So I have to find the tax first of all. So when I do this, I'm going to take my 1248.65 and multiply it by 0.045. Don't forget, you're always moving that decimal 2 places to the left to get that decimal amount, even though there's a decimal in the percent sign. When I do this math, I get $56. Oops, $56.19. This is my tax. So this is the answer because it's saying how much tax will I pay on the sale amount. That's because this again is my sale amount, and this is my tax rate. After I multiply it, then this is actually the amount of tax, $56.19. Do not forget your unit of measure and also what it is. Make sure you have that down. Number 8, a stereo regularly costing $459.99 is on sale. What is the sale price of the stereo? So all I'm doing is I'm finding the 15% and I'm taking it off. So I have 459.99. I'm going to times that by 0.15 because that's my percent there. When I do that math, it's $68.9985. Don't forget, this is what I get, but I now need to round it. When I round this, the 8 tells me to bump the 9 to a 10, so everything gets bumped up. This actually becomes $69 for my discount. Again, this is just the discount, not the sale price. So now I'm going to take the original amount, which is $459.99, minus $69, because that's the discount, and my sale price then, because again, they're asking me, what is the sale price of the stereo? My sale price is $390.99. There's my answer for sale price. Okay. Number 9, it says it's on sale for 30% off, and then there's sales tax. What will be the final price of the television? Okay, this means I have to do everything. I find the sale price, then I find the tax, and then I'm going to add the tax on, and then I finally have paid for the TV and I can walk out of the store. All right, so that means that I have 1,200 times 0.3, because again, 2 places to the left makes it 0.3. That means I get a $360 discount. This is my discount. And again, make sure you label. It does help to see where you're going. So that means I'm going to take the 1,200 and I'm going to minus the 360, which is my discount, and I get a total of $840. Okay, this again, remember, is my sale price. So now I need to take this sale price. Now I'm up at the register, if you think about it. Now they're going to charge me tax. So I'm going to multiply this by 0.0575. All those numbers. Again, 2 places to the left gives me a 0 in front of that 5, 0.0575. So that's my tax rate. That means the tax on the TV is going to be $48.30. This is my tax. Okay, remember tax has an A in it, and that A means I'm going to add it to the sale price. So I'm adding $840 and $48.30. I'm going to add those 2 things up, and when I do add them up, I wind up with $888.30 for my total cost for my TV. There we go. Remember, don't forget your dollar sign and make sure you have 2 numbers after the decimal, because if you're talking money and you have 1 digit after it, I'm not going to count it. If you have 3 digits after it, or 4 or more or something, I'm not going to count that. And make sure you have your dollar sign so I know what you're talking about. Number 10, we have the Smith family going to dinner. So it says their bill is $42.50, but they have a 10% off coupon, and they're going to tip 15%. All right, so let's take off the 10% first of all. $42.50. Remember, if I times anything by 10%, I'm just moving the decimal 1 place to the left. So that means I have $42.50 minus $4.25. Okay, that's my 10% discount. And when I do that, I get $38.25. So this is how much they're actually going to tip on, because this is their bill. So now I'm going to add the 15% tip, so I need to find that out. So I'm going to times by 0.15. When I do that math, I get $5.7375. Remember, I am talking about money. Like I just said, I need to round. So the 7 tells me to make the 3 into a 4, That means it's $5.74 for my tip. So I'm going to add the tip, and I'm going to add the amount I'm actually paying. And when I add those two up, I get $43.99. So this is how much they will pay after they take the 10% discount and then add the 15% tip. Molly wants to buy a skirt. The original price is $29 and the skirt's on sale for 30% off. When she goes to pay for it, the cashier tells her she gets an additional 25% off the sale price. Not counting tax, how much will Molly pay for the skirt? Be very careful on questions like this. You're going to the store, you're going to take 30% off. Then they're taking another 25% off, but that 25% off is off the sale price. So you actually have to do this twice. You can't add it up and say, oh, it's 55% off. You'll get a totally different answer. So do it twice. Don't be lazy. Make sure you do it twice. So we have $29, and we're going to multiply this by 0.3, and that's going to give us an $8.70 discount. So when I subtract it from here, because it was $29 to begin with, I get a $20.30 sale price. So this is my first discount, or my first sale price. Now remember, she goes to the register, she's getting another 25% off. So we're going to multiply it by 0.25, or 25%. I don't know what I just said. So now when we multiply this, we get 5.075. Again, money. The 5 tells me to make the 7 into an 8. 5.08. So now this is in my next discount. So I take the $20.30 minus this here. So that gives me a final cost when I'm done at the register of $15.22 for that skirt that was originally going to be $29. So again, be careful. Do it separately. Do it one at a time, because otherwise you will come out with a different answer. In a survey, 75% of the people polled said they could vote in an upcoming election. How many people were polled if 375 said they would vote in the election? Think about that question I've talked about before. If you can get it into this, because we're going to use a proportion to solve this. What percent of what? If you can get it in this question, it's going to help you out. Okay, so this is going to be a number. This is my percent. And this is going to be a number here. Okay, now there's actually two ways I can do this. I can make an equation, say this is and this is times, right? And the percent's already the percent, so 0.75 if I'm making it into equation. Now, I need to know where that 375 is going. Okay? So how many people were polled if 375 said they would vote? So what we're saying is the 375 is the is. We're saying 375 people is what percent of what number? Excuse me, is 75% of what number? So this is my x value here. So now I can say 375 is equal to 0.75x, and then divide both sides by 0.75. And I get x is equal to 500 people. Okay, so this is one way I can do it. Or, again, using the same question here, this is 375. This is 75%. We're going to leave it at 75. And this is my, excuse me, my x value. Okay, so we can set it up with our proportion of is over of equals percent over 100. So 375 is 75% over x. It's going to wind up giving us the same thing. We have 37500 is equal to 75x. Divide both sides by 75. And then we get, and I'm just going to flip it around, the x is equal to 500. So it's the same thing. It just depends on how you want to go about solving it, but either way would be correct. Okay, number 13. Pretty simple one to do here. We're going to put it as a fraction first. It's 48 out of 60. But again, it even reminds you here, it needs to be what? Reduced. If we have a fraction that's not in lowest terms, whether or not they tell us, we know we have to put it in lowest terms. So I'm just going to make it easy on myself and divide it by 2. That means it's going to be 24 over 30. I'm going to divide by 2 again. And that's going to be 12 over 15. And then I can divide by 3. So that's going to be equal to 4 over 5. Okay, so there's that. My percent, when I do my percent, all we're doing is division, 48 divided by 60, or you can do 4 divided by 5, either way, and it's going to become 80%. So really pretty straightforward here. The hardest part, I think, is making sure that the fraction, remember, always, always, always lowest terms. Okay, number 14, Camilla has $2,250 in a savings account. It earns 4.7% interest. What's the amount of interest she will have if she leaves her money in for 5 years? Remember, we have to remember the formula. I equals PRT. So my I is equal to principal, which is 2250, times the rate, which again is a decimal, so 0.047. 2 places to the left, 0.047 times the time. Remember, time has to be in years, and it is, so I'm good. So once I do this math and I multiply it all out, I get an answer of $528.75. Just remember that the rate has to be a decimal, and this has to be in years. That's our key thing, and make sure that it already says that in our questions, so we're okay. This is the, now again, what does the question say though? What is the amount of interest? Okay, so that is the amount of interest. Remember, we have to watch. Is it interest only that they want, or are we going to add it up? So that is the interest only. This next one here, okay, now this one is asking clearly, how much will Jody pay all together? That means I need the interest, and then I'm going to add it back to the principal. So I'm going to solve it the exact same way, but then I have an extra step. I equals PRT. That means that I is equal to 3500 times the rate is 0.0725. Remember, make that a decimal, even though the decimal's in there, 2 places to the left. And the time, it's years, so I'm good there, so it's times 10. When I do all this math, I actually wind up with 25,375. I need to add this back to my principal right here. So I'm going to add the principal. And when I add it all up, I get a total of 60,375. So this is almost double when you look at it. That's a lot of money. Actually, it's more than double. No, it's almost double. So think about that when you are getting your loans for college and everything. Number 16, this is the, we're actually finding out how much the rate was for the loan. Okay, so they're giving you a hint with a formula, but let me show you how they got that. We're still doing I is equal to PRT. This is the same formula. This is the I, this is the P, this is the R, this is the T. So it says here, he borrows $2,000. Okay, well that's easy enough because that's my principal. So that's going to be the $2,000 right here for that. The rate is what I'm trying to find, so I'm going to leave that as R. The time, it clearly tells me 4 years, so again, that's going to be 4. But now we actually can figure out what the interest is. He paid the mechanic $2,360. That was at the end of the 4 years. He paid all the money back. The $2,000 he borrowed and the interest on top of it. So all I need to do is minus $2,000, and that gives me the $360, which is my interest right here. So that's where we're getting the $360 from. So if they didn't give you the formula, just think through it and think logically through it what you're going to do. Be careful not to put the 2,360 right there. That's not what it is. It's only the interest, because remember the I here stands for interest. That's just the interest. All right, when you do the math here, what you wind up with is you're winding up with 360 is going to equal 8,000 R. Because when I do that multiplication there, that means I need to divide both sides by 8,000. And when I do that, I get 0.045. But remember, that's a decimal amount, and rates have to get, and I use the decimal for the rate in the problem, Like right here, this would be the 0.045, but remember it's actually a percent, so I have to move the decimal 2 places to the right, so it becomes 4.5% for my R. That's my rate, is 4.5%. Russell's beginning balance of his checkbook was 1,785.52. He paid his electric bill and his car payment, and then he deposited a check. Okay, we have to think about this. Let's make sure we write down. You think of lines as you're doing this, but our beginning balance, we always have some kind of a title for it. This is going to be 1785.52. Okay, we have a electric bill. Okay, so I'm going to write that, electric bill. And that's going to subtracting 186.19. When I do that math, I come out with 1599.33. Okay, now I've done the electric bill, so now I need to do the car payment. Okay, so I'm going to do the same thing, car payment, give myself a little space here. And again, I'm subtracting, and this time it's 522.43. Okay, when I do that math, I get 1076.90. And then he had, so I've done the car payment, then he had a deposit of 225. So this time I'm adding, but I'm going to write deposit, because write something on that line. We're adding 225.12. And that's going to be 1302.02. So my ending balance, that's what they're asking here. What is his ending balance rounded to the nearest cent? That's right here. Remember, dollars and cents. 2 places after the decimal, so that's for rounding. There wasn't really anything to round, though. So there's my ending balance. Number 18 here. In January, Jackson weighed 389 pounds. By July, he weighed 159. What is the percent of decrease in Jackson's weight from January to July? Okay, this again, think about what we're doing. This is our percent of change, so it's an increase or a decrease. Remember the formula. It's the big number minus the little number over the original number. I think that part gets a little tricky for people. Don't forget it's the original number times 100. Okay, when I do all that, I've got 389. I have 389 minus 159 all over 389, and then multiplying that by 100. When I do all that math, it winds up being 59.1259 and some more numbers, I think. So we need to round it. And I don't really mind how you round it. If you want to think money, then that would be 59.13, because a 5 would tell me to make that into a 3%. And again, they're talking about a decrease. Or you could just say it's 59%, because a lot of times it's easier just to have sort of a whole number percent. I don't care. Either one of those two answers I would accept. So if you think of it like money, you can do that. Or if you just rounded it to the nearest percent, the 59% is fine. This is another percent of change. So we've got the repair shop charging it cost them $23 to change the oil, but they charge $45. What's the percent of increase? So again, big number minus the little number over the original. 23 is the original because that's what they pay. That's like the first payment if you think about it. Now I'm going to take that, multiply it by 100. When you do all of that math, you wind up with 95.65. Again, if you left it like that, this is a percent increase. Or you could say it's a 96% increase. That would be fine too, either one of those numbers. Number 20, if recycling 2,000 pounds of paper saves 17 trees, how many trees are saved when 5,000 pounds are recycled? These are we're going to use our proportions, so remember it's going to look like that. But let's set it up in words first. I'm going to go in the same order here, pounds over trees. So pounds over trees. Keeps me straight on the next part. That means I have 2,000 over 17, and I have 5,000 over x. When I do the math, I get 2,000x is equal to 85000. Divide both sides by 2000. So X is equal to 42.5 trees. Now, I'll be honest, they're not giving you any kind of direction on this other than just to solve it. On a test, they may round this. They may say 42 trees or 43 trees. So be very careful. If they're doing that, remember the 5 tells you to make this into a 3. So it's going to be 43 trees. You don't just drop it off. Make sure you're doing that correctly. Number 21, same thing. It's talking about words per minute. Okay, so I'm going to go ahead and set it up that way. Words over minute. So that means 57 words per minute means that's 1 minute. That's going to equal 975 words in how many minutes? So that's going to be 57x is equal to 975. I divide both sides by 57 because I'm just using my proportions here to solve this. Makes it really easy. And so I get 17.10. Again, you don't do a fraction of a word in a minute. So that means it's going to be 17 words per minute. Do not forget, oops, because I'm writing this, I'm writing forget instead of per. Don't forget your unit, words per minute. You need to have that. If you just tell me 17, I will mark it wrong because you have to have the words per minute along with it. Number 22, the scale on a map is 1.8 inches is equal to 25 miles. It's on the map, it's 8 3/4 inches to go from Virginia Beach to New York. So what's the actual distance between the two cities? This is the same thing. Now, we haven't actually discussed this in class yet since we've been having all these snow days, but it's the same thing with proportions. The only thing I'm going to do is I'm going to see if I can make the fraction into a decimal. If it makes a nice even decimal, then I'm going to use it. If not, I have to use the fraction. But fortunately, this one does. 1/8, this is equal to 0.125. And 3/8 becomes 8.375. Okay, so that means I'm just setting up my proportions, and I'm going to use inches over miles, the same thing they already gave me. Inch over miles. Okay, so that means that 1/8 is the 0.125 over 25 miles. So that means 8.375 over X number of miles, because that's what I'm trying to find out. What's the real distance between Virginia Beach to New York? So 0.125x is equal to 209.375. I'm going to divide both sides by the 0.125. And X is equal to 1675 miles. Do not forget your unit of measure, because also if you told me inches there, it's wrong. Remember, we're talking about miles because the X is on the bottom here and miles is on the bottom here. So that reminds me what my unit is. Don't forget your unit of measure. Okay, a 16-foot street light has a 10-foot shadow. A 6-foot tall person has how long a shadow? All right, remember we talked about indirect measurement. So I'm going to set up my triangles. This is going to be my light post one. I'm not going to draw the light post because you know I can't draw. And then this is my person one. Obviously, one's bigger than the other, so that's good. So it's tall, 16-foot tall, and a 10-foot shadow. The person is 6 foot tall with an X shadow. Remember what we learned from Miss Brown? She said all we got to do is to set up a proportion is do this, and there's our proportion right there. That means that I have 6 over 10 is equal to 16 over 10 is equal to 6 over X. When I cross multiply, I get 16x is equal to 60. I'm dividing both sides by 16. And then X is equal to 3.75 feet for the shadow. And again, there is my answer there. Make sure you have your unit of measure again. Okay, number 24. We have a commission. Remember, you have to remember the commission is kind of like a tax in a way, but it's something that somebody's going to earn. So they get to keep that amount of money. So if I'm the real estate agent and I get a commission of this, it's based on this amount right here. I'm going to get to keep whatever that amount is. So I'm going to find the percent of a number. So that's 432 0.000 times 0.023. And when I do that math, I get 9936.00. This is my commission. So that's what they earn. It's an earning on top of whatever else they might make. But for selling that house, this is earnings. So they get $9,936 for commission. All right, that's it for the review. I really hope that you guys are there. The review worksheet's also on Edmodo. Look over this. This is only on Edmodo. I'm not putting it in Educanon because it's no questions involved. It's just a matter of reviewing. So good luck and make sure you're studying. Remember, you have a test the next time I see you.